So in the last video we created our floor plan, added the floor plan, the floor beams, and added the floor assembly, and we created this floor layer with the plywood that's going to be on top. So we're going to finish up kind of getting our foundation, our kind of preliminary foundation set by adding this exterior header joist, this plate that's going to sit on top of the foundation wall, and then the footing. So in our drawing, this is where we left off. So you can see we created all of the elements, and so now we need to add the other elements that I was showing you in this kind of completed foundation model. So we can start by opening up a floor plan in the 3D view. So Revit has, you can create, if you go to the View tab and go to Plan Views, that's where you can create all your plan views. And we'll create a structural plan of level 1. And the difference between the structural plan and the architectural plan is that when you create the structural plan, it actually gives you a negative offset, so we can see the footing and the floor joist below. So we can create that. The next thing we want to do is we want to change this from coordination to structural. And so what that's going to do is going to turn off all the architectural walls, as you can see here. We can do the same thing with a 3D view. So if we have our typical 3D view that we created, we can duplicate that, and we can call this, we'll rename it to 3D structural. And we can do the same thing in the properties palette where it says discipline, and it could say architectural or coordination. We'll change that to structural. It's going to turn off those walls, because the difference between these walls that we found under the architectural wall and in the structural is these are the architectural walls, and we can filter them out when we apply the structural discipline. So if we drew structural walls, either from wall structure, it creates a load-bearing wall, and Revit can identify the difference between the structural and architectural wall. So here we could place structural walls, and those structural walls will show up in this view, but the architectural walls will not. So let's get started. The first thing that we'll create, let's create a structural concrete wall, stem wall, or the footing, the top of the footing, basically. So we can go to wall structural, and at this point let's just use a generic, we'll do 8-inch, but all this we can change later. And so here, because it's a structural wall, similar to the structural columns, it wants to do a depth, and in this sense it makes sense. In this instance it makes sense because they know that if you're creating a structural wall, particularly for the foundation, you're going to want it to go, that you're going to set the top of the wall, and then you're going to want to go down, so that the wall is below the floor line, because we're creating a structural foundation wall. So it's automatically set to unconnected 2 feet. So as you can see here, it's going to go, the base constraint will be -2 feet, and the top offset, it would place this at, if we open up let's open up a section view. Also, let's open up the floor plan level 1. Let's open up level 1 floor plan as well, just so we have that for reference. Let's open up this section view, and we'll move it over here so we can see the section view. So we want to create that stem wall below here. In the properties, when we go to create this wall, we'll hit structural wall. We'll do the 8-inch concrete. So right now the base is going to be -2 foot 1, and the top constraint is at level 1, so it would place it the top of the wall here, and it would go down 2 feet. But we actually want this wall to be lower than the plywood, the joists, and then the plate that the wall is going to sit on. So we're actually going to want to place this wall 11.5 inches, which is the 3/4 inch plywood that we have for our floor. It's the joist depth and this plate that's going to sit on top of the foundation wall, which is 1.5 inches. So in our Revit model, when we go to place this wall, we'll actually want it to be what did we say, 11.5, and we want the top offset to be 11.5. And let's create this in our architectural view just so we can use these walls above to place this wall. So you can tab over the walls and then pick, and we can see where it placed the wall. So in this case, we gave it a 11.5 top offset, and it actually went 11.5 inches above the level 1. So let's hit undo. We can get our structural wall back again, and we'll actually want to add a negative value. So the negative offset will cause it to go below the level 1 floor line. So we'll pick lines, hover over the wall, tab once to get it to select the chain of walls, and then pick. And we can see that it gave us a warning that none of the created elements are visible in the floor plan because it went down 11.5 inches so that it places the wall here. And you can see that it placed the wall because we used the offset from the floor line, and we picked this chain of walls, that it placed a concrete stem wall centered on this wall above all the way around our entire perimeter. So now we have our stem wall, and you can see the joists are going over the top. Because in Revit, beams and walls and columns, they want to connect to something. They'll auto join. So if when you place your wall, it was initially in this joist space, it could cause your joists to be set back to the face of this wall. And it can be hard to disallow the join because we're using a beam system. So if it does that, you'll want to delete the wall. You can just hover over it, tab, delete it, and then try to replace it again with the correct offsets. And so although we can't see this bolt wall that we just placed in our architectural view, we can see it in our structural floor plan. You can see it here placed beneath the, so right now it's, because of the structural floor plan, we see our plywood, we see the outline of the joist dashed beneath the plywood, and we can see our foundation wall. And so the next thing we can do is pretty easy as well. So we can go to this foundation and wall, and it says it creates a foundation wall hosted by walls. Or creates foundations hosted by walls, and you can kind of see what it's going to do when you press it. So you can see that it highlights that foundation in blue, and it's another easy way to quickly create your footing. So the same thing, hover over the foundation wall, tab once, selecting the entire chain of wall, and then you can see it creates that foundation. The foundation that it creates, this was the default one, so you can create your own, use one of the defaults, and This is something that the structural engineer or your architect will provide the dimensions for, but for this building we're just going to, generally we're just trying to make it look right and understand that we can actually, if you're called upon to do so, that you can add and edit these elements. So there we have our footing and our foundation wall. The next step is, so here it looks like the floor is just floating, so we'll need to place kind of a header joist here, or a joist that will be at the perimeter. So to do that is also pretty easy. So what we'll do is we'll hit BM for beam, or you can go over here to beam. I believe it's automatically set to BM, not to be confused with the bowel movement. It is a beam annotation shortcut key. So you can click on beam or hit BM in your shortcut keys. Same thing here. We'll click on the pick lines because we're going to use this footing to place this foundation wall. I'm sorry, to place our beam. So we'd want it to be the same depth as the joists. So we'll use the 2x10, and again we will we'll place it on top of this foundation wall. So if you tab, I had to tab a couple times to get the chain of the wall. So we hit beam, pick line, tab, and it will place the beam or the joist. As you can see, we had placed it a little bit higher than it placed it at the floor line going down, similar to like when we placed the foundation wall, and that's easy to fix. We can go over here, select the chain of beams, so the beams are all connected. Tab over, pick the entire chain of the beams. On the properties palette, they have a start level and an end level offset. So if you wanted a sloping beam, you would create, you would give, these two values would be different. So if you wanted your beam to slope down one direction, you would have two different values. But here we just want it to be -3/4 or the thickness of the plywood that's on top of the floor. And you can see that it'll move it down here to be below the plywood. And right now it's centered on this wall above, and for that we can, I think the best way to go about changing that would be to offset. So instead of having to go and align or move all the beams to this edge here, we can offset all of the beams. So let's get a dimension that we'll need to offset, 1 5/8. So let's offset this beam 1 5/8, this chain of beams. So let's go O for offset, O space, or enter for offset. We can do 1 5/8, and hopefully we can get the chain of beams. This is one thing that's kind of frustrating for me. It doesn't always work. Let's not hit copy as well. We don't want to copy. So there we go. So we uncheck the copy, go to the outer part of the beam, tab, and then hopefully, as we can see, it placed all of the beams, or all of the joists, because this would be like the header joist that's going to be around the perimeter, at this outside, exactly lined up with the face of the stud, plywood, and now this joist is all aligned. We then can also place, and then that was global because we selected the beam around here, so it did it in all the locations. And then what I'm noticing too is we can see our joists are actually into that on the we cut another section here. We can see that our sections are, our joists are actually into this header joist. One thing to note too, because these sections we're cutting, if you go to annotate and you know you're cutting a section, these sections are set to, view, and you're cutting a section. Let's hover over here, let's see, section, that they're not showing up in our structural plan. And that's because these are set to the architectural discipline. If we were to set these to coordination, we should see them in all the views now. It's a way that you can have a structural and architectural sections. So like, let's say you have some structural sections cut in here. If they have the discipline set to structural, they will not show up in a plan that's set to the architectural discipline, and vice versa. Setting them to coordination means that they show up in all views, because it implies that you would want these sections to appear in every single view for coordination purposes. So if we go to this other view, we can right click, go to view, or you can actually, I think, let's see, there's probably another way to do that as well. I know you can find it on the project browser. Right click and go to view, or double click on this to go to view. There's several different ways to do that, but I usually just right click because it's quicker, and go to view, and we can see that this is into that cavity. We now see them on the structural plan, and let us edit this beam system. Basically we want to edit the boundary. So you can hover over the edge, because basically what it's doing is it's creating an entire perimeter boundary for our beam system, so that we can control our beam system. So if you select this beam, go to your properties, so a lot of things will be locked out, because what's controlling this beam or joist is this beam system. So we have this structural system, this beam system, and we want to edit this boundary so that the beams or the joists are no longer into this end joist. So you might have to tab over. Sometimes it's hard to get the beam, what you need to get selected in certain views, so often it's good just to go into another view to try to select a beam system. Sometimes it can be easier. You can say I can just hover over here and get that beam system, and then I can go back into the plan view, or even the section or in 3D view. I can get the beam system to highlight. So we'll get that highlighted so we can edit it, and then we'll go up here to edit boundary. You can also double click on a beam system that you have highlighted to select it. And so now we can change the boundaries of this beam. As we can see kind of grayed out here that this is that beam we added, and we can offset this whole chain of beams. We'll want to offset it 1.5 inches, the thickness of that joist. Same thing over here, we don't want it to be copied. We want to hover over, try to hit tab to see if we can get the entire chain of walls. And this is the thing I was saying before, sometimes it's kind of tough to get it to do that. There we go, see I tabbed over, or I hovered over, hit tab, make sure it's going the right direction, and then select. And actually we needed to go the other way, so we'll offset again. Looks like we were still in the command. Hover over, tab, and you can see that light blue line. I'll zoom in here so you can see it. And we'll pick, and because it didn't copy, it moved all those lines around the entire perimeter for the beam system into, or back behind this joist. And so if we go to our section view, we can see, yes, it did that. And if you also notice in the 3D view, we no longer see the beam profile sticking through, because we moved all those beams back. And that happened globally because we're using this beam system which controls all of that. So now we're almost done. Actually, we've got our foundation wall, our footing, our header joist that's going to make up the perimeter, and so all we need now is this sill plate. So For the sill plate, I'm going to use, looks like we have about 6 3/8 from here, from the inside footing to the face of this. So we may want to use a 2x6 flat stud. In this case, depending on what you have, I think I may want to have my foundation wall, I think I want it to align with this. Now this could vary on your particular house, because what is going, so if you had like brick per se, you might want a wider footing and have a ledge in here for the brick to come down. That would be the typical construction. So, but for this instance, and this is something you can change again later, so for this instance I'm going to align this back 1 5/8, so my face of stud, my header joist, and my stem wall or foundation wall all line up. So again, we can go back to our structural plan. We can find this footing out here, this foundation wall, and let's offset that in 1 5/8. So we can do 5/8 and tab, and it looks like, let me see, it looks like it might not put it in the correct location. Oops, because I went the wrong direction. So let's offset this stem wall. You can see it dashes in the line, which is kind of nice to show you that there's something underneath here. So let's go the other direction. And you can see it lined this edge up. So I'll undo that just so that, because there was a little confusion there. So we'll offset at the 1 5/8, make sure copy is unchecked. Go to the inside of the foundation wall, hit tab once, see that it's all offset the correct location and that you have the chain of walls, and then pick. And you can see that because we added this footing is attached to this wall and everything moved together, which in Revit makes it really nice to be able to modify things because you have that control. So we only have one more element that we need to add, which is that plate, that top plate that will be sitting on top of the foundation wall. So in this case, we have an 8-inch foundation wall, so I'm going to use a 2x8 flat. And so also too, if you wanted to change, once you've got these elements in, they're pretty easy to modify. So let's say we want a 12-inch, foundation wall. We can make these changes as we go through, and we can add a ledger on either this side or this side later on, but we'll just get on these elements now. So however your house is going to end up being, if you get these elements in, we can later go through and modify them, and I'll show you how to do some of those modifications. So we're going to leave it as the 8-inch with this footing, and we're going to add this top plate. This top plate, I want to create it just like we did the others, where we're going to use this foundation wall. What I'm going to do is set a work plane. So if you're in the architecture tab or the structure tab, there is a work plane. So similar to, I believe, AutoCAD also has a similar feature where you can set the UCS to the face that you want to work on. So in this instance, instead of giving it a level offset like we did this wall, where we just left it at level 1, we just did negative values to get the wall where we wanted, we can actually set a work plane. So if you go up here, you can hit set work plane. It's under the structure or the architecture tab. So architecture tab in the same location, structure, set work plane, and then dialog box will pop up. It'll ask you to either name a plane. So right now it should be set to level 1, but we want to pick a plane, and this allows you to pick any surface in here to use as a work plane. So in here, I'm just going to pick the top of the foundation wall, select that, and then now if we go to show work plane, it shows the work plane location. So if you were to go set work plane again, you could pick level 1, hit OK, and then it's showing that the work plane is at level 1 now. So we can set that again. We'll pick that plane, set the top of this wall, and that'll be our work plane. And you can see when you go to set again, it's telling you where it's at, and you can hit show and it'll show you where the work plane is. So I don't need to see this work plane while I'm working because I know I set it. So I'm going to turn off show work plane. Then I'm going to go to beam again, and that's where we'll find our 2x10, 2x8 other wide flange beams that we've loaded in. I'm going to put a 2x8 top plate. Now if I were to then pick this chain of wall, it's going to put the 2x8 vertically because that's the way that the family is designed. That the depth is 7 1/4, and this dimension up here is 1.5 inches. So in order to make less work for us, so if we wanted to, you could select this. You could select this this beam or joist, and then give it a rotation, so of 90, and it'll rotate it so that's in the correct location. But an easier way to do this would be to go back into your beam command. It allows you to edit and change what you're placing before you place it, so you'd want to hit edit type, duplicate, and we'll just call this 2x8 plate. We'll change these values, so this will be 7 1/4, and we'll change this value to be 1.5. So now when we put in this 2x8 plate, it will be in the correct orientation. And let's change over here. They have the justification values that you can change before we place it. So let's change it to bottom, so it will place the bottom where we want instead of having to move it again later. And so we'll see if this works. So we'll hit pick line, we'll select this chain of walls, and there you have it. You got a beam top plate. Put it at the top of this wall in the correct orientation, and it looks like the offset, just like we were looking at some of the other placements, is a little off. Also, I noticed it didn't connect like the other ones did, and so it looks like it's giving it a looks like they're not connected, but that's okay, we can fix that. So the first thing let's do is get this offset so that we have it at the face. Let's offset this plate, this 2x8 plate. As you can see in this drawing, you can take a measurement. It looks like it's 3/8 inch from there, so that's offset, and we'll do 3/8. And we possibly are not going to be able to get all of them at once, so we may have to go through and pick each one, and then we'll fix up these corners. So we'll go through, select all of the plates that we just added, make sure you're picking on the right side so that it offsets the correct location, and just keep going through and picking all of the top plates. This can be a little bit frustrating sometimes when it doesn't come in the correct way you want it, but often it's a lot better than what other software could get you. And there's also often another way to go about it. Like we could mess with more of the settings to see if we could get it to set the correct location. So now let's try to fix these corners. You could try to trim, so in the Modify tab, you could just try to trim, extend, and see, and it looks like that it's going to trim and extend these corners. just fine. And so, and as we go through and do that, you can see that it's actually putting it into a back into a linked or chain of beams, or in this case the beam is a top plate. So one of the things you could have done is done this process first, gone through and trimmed, but either way we would have to either offset or trim first. And in some cases they don't work, and they're just funny little Revit reasons why that may be the case. So you can try to trim extend and see if that works. And my experience is sometimes it doesn't make sense why it doesn't work. And so, but there's lots of different ways to skin a cat, as they say. So up here we have beam column joins, and if you hover over, you can see that it changes the way that it joins. And so in this instance we may need to manually try to do that. Notice it still kind of makes them overlap, but at this point we can try to trim, extend, trim to see if we can get them to look like we want them to. Let's see here. If all else fails, again, there's lots of different ways to do this. There's something about these beams, the way they just don't want to connect. So what I'm going to do, though, my last effort, because I don't want to, usually I just don't want to mess with it long enough. I know lots of ways to force it. So if you select a beam, beams are set to auto join, so they typically are set to join. So if you hover over this last node or grip, right click and disallow join, then we can get them to join, because now they're not going to want to join with each other, but that's okay, because I just want them to lap correctly, and now we can trim, extend and get them to join correctly. Difference between trim, extend is trimming, extending is more like the AutoCAD trim extend, where you use a surface to kind of cut, where the actual trim, extend to corner is more like the fillet command. So does that make sense? The trim, extend is more like fillet in Revit, where you're taking two entities and combining them to add a corner, and a trim, extend single element is more like the extend, cut, and trim feature in AutoCAD, if you're familiar with AutoCAD. So we got that corner. Let's see if we can get these other corners to trim without hassle, and these ones are going to be fine. And you know, as you go through these, you might find easier ways to do things, something that I didn't mention. Definitely bring it up, and you just let us know, because there is a lot of ways to do this. I don't know all of the ways. Google search often is your best friend with some of these things. So definitely, if you find an easier way to do something, let us know, so that we can, all be learning together. And let me know if you have issues and can't get these to do, because to join or anything, because often you wouldn't want to quit at this point, because you want all of these to be accurate, so that you can see that yes, this top plate in the field, they would extend it so that it kind of rounds out this corner. So you might not know that you can disallow the join, and often there might be a reason, something that we could change to allow this join to happen, that I don't know off the top of my head, especially since the others are working just fine. But definitely, if you find a way, and I might even do some research, just looking at the Revit boards and the Autodesk help, to see if there's reasons why things do that you can adjust settings to see exactly why something isn't working, and we can sometimes it's good to just go through and try to figure that out. So now we've got our foundation, we got our footing, we got our stem walls. In the book, we can look up kind of like general guidelines for spans for these joists. Some of these joists are going to need intermediate, they're going to need additional footings and things to support that. But for now, we've got our kind of base of our building. We've got our footprint. And so in the next video, we're going to go over just placing these interior walls, which will just be a little bit more of the wall types, and start making this look more like a building, more like a home. Right now, it just looks like a footing, a foundation. Before we go, we'll just rename this other 3D view. We'll just rename it to 3D architectural, so we can keep track of what views we have and where we can go to find the information. Let's see if I can spell architectural. Sorry, I've got some sausage finger issues here. And there it is. So now we have our view, our architectural view, our structural 3D view. We have a few sections. And so next, to complete this, we'll start filling out the interior, getting that all placed, and then we'll work on getting our roof in and start adding some doors and windows. So we will see you in the next video. Thank you.